Let's go through this study guide to help you get ready for your first test of the quarter. This study guide gives you tips on how to prepare. If you were taking this test in person, this would be, what you were using as you were getting ready. And since you're taking this test online, I feel like you should use this study guide to help you organize your notes and your materials so that you can quickly find all of these different things and answer all of the questions correctly and as fast as possible. So I'm giving you 3 tips here on how to be successful on the first test. First of all, you need to know the language, the different words. And then second of all, there's this list of different concepts that I am going to ask you questions about on the test. So you need to know those specific concepts. And then number 3, just make sure you're getting plenty of practice solving problems before you tackle the test. So what we're going to look at first is this list, the success criteria. So this is a list of the topics that I will look at this when I'm putting your first test together, and every question on your first test is going to pertain to one of the things on this list. You're not going to see any questions at all about something that is not present on this list. So this is definitely the most important stuff to study, and I usually write the test in order. Like the first 1 or 2 questions will be on this topic, and the second 1 or 2 questions will be on this topic. So this is a great way to organize your notes. This is also in the order that the material has been presented to you. So maybe your notes are already organized in this way. And I want to go through each one of these one at a time just to make sure you're really clear on what each of these things are referring to. So first of all, drawing a molecule using Lewis structure, condensed structure, and align structure. This is the stuff from section 11.4. This would be in your first sapling homework assignment, homework 1. So maybe you're given a Lewis structure and asked to draw it as a condensed structure, or asked to draw it as a line structure, or I could give you a line structure and ask you to turn it into a Lewis structure. It could be anything like that. Second thing, identify the 13 functional groups by name and by structure. This was in section 11.5, and you have all the functional groups in 3 tables in your textbook. They are in tables 11.2, 11.3, and 11.4, and these are all going to be around page 384 to 386, somewhere in that ballpark, depending on what edition you're using. So you don't have to have these memorized, obviously, but just have that table handy so that you can find them. Predicting the structure, or predicting the solubility of a molecule based on its structure. That's in section 11.6. You are given a list of guidelines for polar molecules versus non-polar molecules. Polar molecules are ones that are soluble in water. Non-polar molecules are ones that are soluble in organic solvent. Constitutional isomers we covered in section 12.2. It was kind of one of the last things in that section. Constitutional isomers are molecules that have the same formula, but they have different connection. So their atoms are put together in different order. Identifying the correct name of straight chain, cyclic, and halogenated alkane. So emphasis on this, identify the correct name. You're not going to be coming up with names, you're just going to be identifying the correct name, like multiple choice type of a thing. So that's in sections 12.2 through 12.5. We covered that over a lot of different sections. The next thing, ranking alkanes by increasing boiling or melting point. That is actually a topic that's not being covered in the online version of this class. This is something that was tied to a lab that you would have done if we were in person. So for us this quarter, that is not something that you're going to see show up. Identify the correct name of straight chain and cyclic, alkenes and alkynes. Again, notice that it says identify the correct name. So that's in section 13.1 and 13.2. Make sure you can pick the correct name out of a list. Identify cis and trans. This we covered in 13.3. So a cis isomer is one where the two substituents coming off of a double bond are on the same side, and a trans isomer is where they're on different sides. Identify the single structural feature that's present in all synthetic female sex hormones, but not present in the natural hormones, estradiol and progesterone. This is in section 13.5. This is one where we went through a PowerPoint. So you have that PowerPoint slide on Canvas that you can access and find. It's a functional group, a structural feature, functional group. That is present in all the synthetic female sex hormones. Predict the products of hydrogenation, halogenation, hydrohalogenation, and hydration. For most 131 students, this is the hardest part of this first test, the material that we cover on the first test. This is in section 13.6, 4 different reactions. Just practice, practice, practice. Classify a compound as aromatic or not aromatic. This was in 13.9, 13.11, and 13.12. And this is really just yes or no, does it have the aromatic ring? If it has the aromatic ring, then yes, the compound is aromatic. And if it does not have the aromatic ring, then no, it is not. And don't be confused. That is not an aromatic ring. You have to have the alternating double and single bonds to be considered aromatic. Identify the correct names for straight chain, branched, and cyclic alcohols. Again, you're just identifying the names of the alcohols. That's in sections 14.1 and 14.3. Reactions of alcohols. Show how to convert the alcohol to the alkene. That is 14.5. And we, if I remember correctly, we did not do predict the major product. We just did the reaction, didn't worry about predicting the major product. Cross that out. Show how to convert an alcohol to an aldehyde, carboxylic acid, or ketone. That's in the same section, 14.5, the oxidation reaction. Explain the source of a hangover. That's in section 14.6. That's a PowerPoint. So what molecule causes us to have a hangover? And why ethanol is an effective treatment? That was on the very last slide. Listing the advantages and disadvantages of using diethyl ether as a general anesthetic. That is section 14.8. Classify a pair of molecules as being constitutional isomers, stereoisomers, or not isomers. We started talking about that in section 15.1, and it just kind of continued all the way through all of chapter 15. Constitutional isomers are going to have different connectivity, different connection of the atoms. Stereoisomers have the same connection, but they have a different shape. which we're going to see reflected across the double bond. So it could be like that, those would be stereoisomers, or you're gonna see it reflected using wedge dash notation, where substituents might be different on the wedge and the dash, but otherwise the same. And then not isomers would be molecules that have different formulas. They just have a different number of atoms. Locating the chirality center of a molecule is in section 15.3. This is finding a carbon that has 4 single bonds to 4 totally different things, 1, 2, 3, 4. Drawing a molecule using wedge and dash notation to represent a particular 3-dimensional shape. Really, what I want you to understand here is that the wedge means that it is sticking up, and the dash means that it is sticking down. You're not going to be drawing anything because you can't hand me a piece of paper and have me grade it. So you're not going to be drawing anything on this test, but being able to understand what the wedge means and understand what the dash means. Drawing, again, drawing an enantiomer, you're not going to draw anything. So this would be for you more like recognizing an enantiomer. I stopped finding the sections for you. Drawing 3-dimensional shape, that's also in 15.3. Drawing an enantiomer was in, I'm flipping through my notes, hold on. We did it in a little bit in 15.3 and also in 15.6. So for you guys, this is really going to be recognizing the enantiomer because you're not going to be drawing anything. And in 15.3, we were drawing the enantiomers of wedge dash notation things. And in 15.6, we were drawing the enantiomer of Fisher projection things. And then last but not least, converting between wedge dash notation and Fisher projection of a molecule. So this is really, if you're looking at a Fisher projection, I want you to remember that it's bow ties across with dashes on the top and the bottom.